Risk management in projects. Agile project management. Risk management in projects. Whether launching a new product line, implementing a new technology, or constructing a new facility, the path from initiation to completion is rarely smooth. Unexpected events can arise, threatening project timelines, budgets, quality, and overall success. Purpose and objective. Effective risk management in projects primarily aims to minimize the negative impact of potential threats and maximize opportunities for success. The key objectives are to explain the importance of proactive risk management in operations projects. Purpose and objective. Outline a structured process for identifying and mitigating project risks. Describe the mechanisms for monitoring and controlling risks throughout the project lifecycle. Illustrate the practical application of risk management through a real-world example. Highlight the key takeaways for effective risk management in operations. Process flow. 1. Risk identification. This initial stage involves systematically identifying potential events or conditions that, if they occur, could negatively impact project objectives. Techniques such as brainstorming, checklists, lessons learned from past projects, and expert judgment are commonly employed to achieve this goal. 2. Risk analysis. Upon the identification of risks, a thorough analysis must be conducted. This stage often involves the use of both qualitative and quantitative techniques. Qualitative analysis prioritizes risks based on their perceived severity and probability, using high, medium, and low scales. Quantitative analysis, where feasible, assigns numerical probabilities and impacts to risks, allowing for calculations such as expected monetary value. 3. Risk response planning. For significant risks, the project team develops strategies to mitigate threats and exploit opportunities. Identifying and mitigating project risks. Effective risk management's foundation lies in identifying potential risks and then developing appropriate mitigation strategies accurately. Risk identification. This involves systematically uncovering potential events or conditions that could negatively affect one or more project objectives. Risk mitigation. Mitigation strategies aim to address potential threats proactively. Mitigation plans should be realistic, actionable, and assigned to specific individuals or teams for implementation. Monitoring and control mechanisms. Risk management is not static, it requires monitoring. This involves tracking identified risks, their triggers, and the effectiveness of the implemented risk responses. Control. Risk control involves implementing risk response plans, tracking their effectiveness, and making adjustments as necessary. Key control activities include executing risk response plans, implementing the planned mitigation, transfer, or other risk response strategies as outlined in the plan. Evaluating response effectiveness, assessing whether the implemented risk responses have the desired effect on reducing the probability and/or impact of risk. Implementing contingency plans, activating backup plans if identified risk events occur. Managing changes, handling any changes to the project scope, schedule, or budget in a way that considers the potential impact on existing risks and the emergence of new risks. Updating the risk register, regularly updating the risk register with new risks, changes in risk status, the effectiveness of risk responses, and lessons learned. Agile project management. Traditional, waterfall, project management approaches can sometimes prove too rigid and slow to adapt. Agile project management offers a more adaptable and iterative approach, prioritizing collaboration, ongoing feedback, and incremental value delivery. Although frequently associated with software development, its principles and methodologies are increasingly finding valuable applications in operations management. Agile project management, process flow. Unlike the sequential phases of traditional project management, Agile follows an iterative and incremental process. The typical flow involves 1. Envisioning, defining the project vision, identifying stakeholders, and outlining high-level goals. 2. Sprint planning, breaking down the overall project into smaller, manageable iterations called sprints, typically lasting a few weeks. The team collaborates to select the tasks to be completed within the upcoming sprint. 3. Daily scrums, or stand-ups, are brief, daily meetings during which team members communicate their progress, outline their plans for the day, and identify any obstacles they encounter. 4. Development and implementation, the team collaborates on efforts to fulfill the tasks outlined in the sprint backlog. 5. Sprint review, upon the completion of each sprint, the team presents the accomplished work to the stakeholders, soliciting their feedback and input. 6. Sprint retrospective. The team reflects on the past sprint, identifying what went well and what could be improved for future sprints. 7. Release, delivering the working increment of the product or service. 8. Continuous improvement. Based on feedback and retrospectives, the process is continuously refined throughout the project lifecycle. Agile principles and methodologies. Agile project management is underpinned by core principles outlined in the Agile Manifesto. These principles emphasize individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change by following a plan. These principles are brought to life through various Agile methodologies, with Scrum and Kanban being among the most popular. Scrum, a framework that structures development in time-boxed iterations, sprints, with defined roles, product owner, Scrum Master, development team, and events, sprint planning, daily Scrum, sprint review, sprint retrospective. It emphasizes self-organizing teams and iterative progress. Kanban, a visual workflow management system that limits work in progress, WIP, and ensures a continuous flow of value. It uses a board to visualize tasks and their progress through different stages. Kanban is more evolutionary and can be overlaid on existing processes. Other Agile methodologies include Lean, Extreme Programming, and Feature-Driven Development, each with specific practices and focus. Applications in operations management. While initially conceived for software development, the adaptability and responsiveness of Agile make it increasingly relevant to various aspects of operations management. Some key applications include new product development. Agile's iterative approach enables rapid prototyping, early customer feedback, and quicker adaptation to market demands throughout the product development lifecycle. Process improvement. Applying Agile principles to process optimization projects enables incremental improvements, faster implementation of changes, and continuous refinement based on performance data. Supply chain management. Agile can facilitate better collaboration and communication among supply chain partners, enabling quicker responses to disruptions and changing customer needs. Maintenance and repair operations. Utilizing Agile methodologies can enhance the efficiency of maintenance schedules, prioritize tasks based on urgency and impact, and facilitate improved communication among maintenance teams. Project implementation, ERP systems. Breaking down large-scale operational system implementations into smaller, manageable sprints with regular stakeholder feedback can reduce risk and improve alignment with business needs. Remember, the more you learn, the more you earn. Never stop learning. Life never stops teaching.